Hi folks, we're going to take a look at number 12 from page 403. So let's see, they tell us that this bridge across the valley is 150 meters in length. So I can add that to my diagram. It wasn't included, so this bridge here is 150 meters long. All right, they tell us that these angles are made, I guess, to the bottom of the valley, and they want us to know how deep the valley is to the nearest meter. All right, so let's first of all indicate what we're looking for. So we're looking for this depth here, so I'll call that D. All right. Now, we would have been able to solve this problem using right-angled trigonometry, but it was quite an endeavor because you had to split this 150 into x and 150 minus x and solve a system of equations. But now that we have the ability to work with non-right triangles, we can probably do it a little quicker than before. Okay, so the one thing we have at our disposal is that new equation called the sine law. So let's see if that applies. So first of all, strategy. How am I going to find this D? Well, working with this larger triangle, if I could say find this side length, well, this side length is not just a length in the big triangle, it's also the hypotenuse of this right angle triangle. And so if I were to find this side length, I'd have a side and an angle in a right angle triangle, which is enough information to solve for anything else that I need. Of course, I could also do this with that side of the big triangle, which is the hypotenuse of the right-hand right angle triangle. Okay, so I'm actually going to do both just to show you that all this stuff does make sense and it works, but of course, the expectation is that you not do both. All right, so let's give this a name. Let's start with this side here. I'll call it X. So let's see first of all if the sine law applies. All right, so I'm looking for this side length and I know its opposite angle, so that's good, I need that. And this is my given side length. I'm not given its opposite angle, but it's something easy to calculate. So because of that, I'm able to use the sine law. So let's start by calculating that angle. So we got 180 minus 60 minus 54, so 66 degrees. All right, and so now let's set up our equation. So because I'm looking for a side length, I'm going to use the particular version which has the side length in the numerator. So side length divided by the sine of its opposite angle, so 54. So notice here how I don't use, A over sine A, B over sine B. I try to think about what those represent. Side length over the sine of its opposite angle. Okay, and then on the other side of the equation, the known side length, 150, over the sine of its opposite angle, which is 66. All right, and because we have this numerator, the variable in the numerator, it makes it a lot easier to solve because I just have to multiply both sides of the equation by sine of 54. So 150 times sine of 54 divided by sine of 60. And notice how I wait till the very end to do my approximation. Okay, so let's do that here. 150 times sine of 54. Okay, divided by sine, that's 66, not 60. Okay, divided by sine of 66, and that is 132.8. All right, so now that I have this hypotenuse, I can now work with my regular primary trigonometric ratios. So I have the angle, I'm looking for the opposite side, and I now know the hypotenuse. So opposite hypotenuse, that's sine. Okay, so sine of 60 degrees is equal to the opposite, which is D, the thing I'm looking for, over the hypotenuse, which is that length I just found, 132.8. And so D is just equal to, and I still have that in my calculator, so the 132.8 times sine of 60. And so that is 115, and they asked to the nearest meter, so that's how we'll leave it, so 115 meters deep. Okay, and you can see this is much, much easier than what we would have had to solve without having access to the sine law. Okay, so you might want to just stop here, or if you want to see how we get the same answer looking for side length y, let's go and do that one there. So I'll do this a little quicker here. So let's set up our equation. We have y over the sine of its opposite angle, which is 60, okay, is equal to, and again, I'll use the same ratio here, 150 over sine of 66 degrees. So y is equal to 150 times sine of 60 over sine of 66. So y here is equal to 150 times sine of 60 divided by sine of 66, and that's equal to 142.2. And so now if I'm looking for D, all right, here's my angle 54. I'm looking for the opposite side. I know the hypotenuse, so again, I'm going to use sine. So sine of 54 degrees is equal to the opposite D over hypotenuse, which is 142.2. So D is equal to, and I still have that on my calculator, 142.2 times sine of 54, which again is equal to 115 meters. Okay, so not surprisingly, since we actually proved the sine law, I'm not surprised that I get exactly the right answer. All right, so just to recap here, excuse me. First thing was to come up with a strategy to realize that I could use a sine law to find one of these other sides. And then one of those other sides became the hypotenuse in one of these right angle triangles, which I could then use to find the depth here. Okay, that's it for this one.